Hello guys, my name is Nikander, I'm a professional blockchain developer, and in this guide we'll see how to work with composite types like maps, structs and messages on Ton blockchain. Let's get started. Open VS Code, create new project, npm create Ton latest. Project name composite types, contract name maps, structs, messages. Select an empty Tact contract. Move to the project directory, clear the console, and now we are ready to write our smart contract code. Open the contract in Contracts folder. First, let's define a struct. Struct, short for structure, is a custom data type that allows developers to combine data items of different kinds. Structs are used to create a data model that represents an object with multiple attributes using a single entity. We define a struct called token info. It is a custom data type that groups together two properties of a token: ticker, a string representing the token symbol, and decimals, an integer indicating how many decimal places the token uses. Let's define a map. Map is a fundamental data structure that stores data in key-value pairs. Each unique key points directly to a value, much like looking up a word in a dictionary to find its definition. Allowed key types in Tact maps: int and address. Allowed value types in Tact maps: int, bool, cell, address, struct, and message. Here we declare 4 different maps as state variables within the contract, each using integers as the keys. Me1 maps to token info structures, Me2 to boolean values, Me3 to integers, and Me4 to addresses. The same way, we declare maps with addresses as keys. There is no need to initialize maps inside the init if they are empty. But for example, we can initialize Me2 with key 1 pointing to true. Create a new setKeysReceive function. In the map Me1, we set the value at key 17 to a new token info struct with a ticker of duref and 9 decimals. In the map Me2, we set the value at hexadecimal key to true. In the map Me3, we set the value at key 2 to the power of 100 to 2 to the power of 200. In the map Me4, we set the value at key -900 to the address of token duref. In the map MA1, we set the value at the address of token duref to a new token info struct with a ticker of duref and 9 decimals. In the map MA2, we set the value at the address of token scale to true. In the map MA3, we set the value at the address of token duref to the value of 1.75 in Ton coins. In the map MA4, we set the value at the address of token scale to my address. My address is the address of this smart contract. Create delete keys receive function. In Tact, we can delete an entry from a map by setting its value to null. We can copy the code from setKeysReceive function, then set all values to nulls. Create clear receive function. To reset all the map variables in the smart contract to be empty, we can set each map to empty map, which creates a new empty map for each variable. This operation clears all the existing data within the maps, ensuring that no previous entries are left, effectively reinitializing the contract state to have no mapped data. Now we can talk about messages. Messages are almost the same thing as structs, with the only difference that messages have a 32-bit integer header in their serialization, containing their unique numeric ID. This allows messages to be used with receivers, since the contract can tell different types of messages apart based on this ID. Tact automatically generates those unique IDs for every received message, so we don't need to specify this manually. We define replace as a message type that includes a map named items. Create a receive function that handles a replace message, replacing the contents of the mi4 map with the new items from the message. This allows for efficient bulk updates of the map data in one operation. Create a getter function named oneitem that takes an integer key as a parameter and returns an address. This function accesses the mi4 map and retrieves the address associated with the specified key, allowing us to query the map for specific values efficiently. Create a getter function named itemCheck that returns a string. This function checks the mi1 map for an entry at key 17. If the entry is not found or if it's null, the function returns not found. Otherwise, it retrieves the token info struct associated with the key 17 and returns its ticker. The double exclamation operator is used to assert that the returned value cannot be null, ensuring that the ticker is safely accessed. Create a getter function named allItems that returns a map where each key is an address and each value is a token info struct. This function simply returns the entire contents of the MA1 map, allowing us to easily access and utilize all stored items in this map directly. Our contract is ready, so we can build it. npx blueprint build. Great, we have no errors. Before testing, let's discuss one more topic called optionals. Let's declare integer variable called opt. Then try to initialize it with null inside the init. Build the contract, and we got an error, because variable opt can't be null. If we want opt variable to be able to store null or be optional, we need to add a question mark after its type declaration. Now we build the contract and there is no errors. Great, let's do some testing. Open the test script in tests folder. Create test should set keys correctly. Initiate a transaction using the send method on the maps structs messages contract instance. This transaction is sent by the deployer's sender address, carrying a value of 0.05 ton coins, with the intention to invoke the setKeys function. Check the transaction was processed successfully. Retrieve the ticker value using the itemCheck getter function from the smart contract. Log this ticker value and check it equals duref, confirming that the key value pair was correctly set and retrieved. Fetch an address using the key -900 with getter function oneitem. Log this address and then ensure that the retrieved address matches duref token address. Run the test npx blueprint test. Great, as you can see, we got the duref ticker and duref token address. Create new test called should delete keys correctly. Before deleting the keys, we need to set them first, so send set keys message, retrieve and lock ticker value, send delete keys message, check the transaction is successful, get the ticker value after deleting the keys, check that the item check function returns not found. As you can remember, if the value is null, item check should return not found. Run the test. Great. We have ticker durov before deleting the keys and not found after deleting the keys. Create the test should clear all maps correctly. Set the keys with the message set keys. Get the value of all items function and log the size of all items. It should be 1. Send the message clear and verify the transaction is successful. Get all items after clearing the maps, log the size of all items and check that the size is 0. Run the test. Great. As you can see, all items size before is 1, all items size after clearing is 0. That's it for today, folks. Thanks for watching. If you found this video helpful, please click like and subscribe for more updates. Don't forget to hit the bell icon to get notifications about the latest content. Your support helps me create more useful guides like this one. See you in the next video.